Hello, welcome to Physics World. Our day starts with observing different things outside, like walking of a boy, a student running on the road, a moving car, a moving auto, a moving truck, etc. If you watch movies and TV channels, you can observe that motion of a satellite, motion of a rocket, motion of planets around the sun, especially our planet Earth around the sun. If you observe all these types of examples, you can observe that all these are not the same type of motion. There are different types of motions. So why do you have different types of motions? Or at least we should know that what type of motions generally we observe daily most of the times. So to explore these things, let us start the chapter called motion. Let me write the types of motion. A moving car, it is linear motion, and a moving bus on the road, what type of motion? Yes, you are correct. It is again linear motion. At rotating around the sun, what type of motion? Yes, it is circular motion. Okay, you watch cricket many times. Yes, so then see, a batsman hits the ball. Batsman hits the ball. What type of motion of the ball? Yes, it is curved motion. Right. Now, a football player hits the ball, or a football player kicks the ball. Then what is the path of the ball? Football. Kicked by a football player. What is the path of the ball? Yeah, maybe this type of, yes, of course you are correct. It is curved motion, but specifically it is called projectile motion. A spring is stretched and released. Then what happened to spring? The spring will move back and forth. Motion of a spring. What type of motion it is? Yes, it is called vibratory, or you can say oscillatory. There is a slight difference between vibratory and oscillatory, but here we don't discuss the difference. But vibratory or oscillatory is nothing but back and forth motion, or you can say to and fro motion, like motion of a pendulum. So once you check all these examples, you get to know that we are not having one type of motion. We have linear motion, circular motion, curved motion, projectile motion, vibratory or oscillatory motions, etc. Different types of motions we have. But in this chapter, our focus is on linear motion. Before discussing about what is linear motion, let us understand about the difference between rest and motion. See the diagrams here. A person P, a person Q. This person P is at the location O, or at the position O at time t equal to 0. Now, the time is increasing, 2 seconds, and then after 4 seconds, and after 6 seconds. Even though the time is increasing, the person P still at the same location O. Then we say that the person is at rest state. Now see the person Q. The person Q at O at time t equal to 0. After 2 seconds, he is at A. After 4 seconds, he is at B. After 6 seconds, he is at C. So when the time is passing, he is changing his position. The position is changing. Then we say that this person is in motion. So the difference between rest and motion is, rest means if any body doesn't change its location with respect to time, then it's called rest. Let me write here. Body does not change its location with time, then it is rest. Now, motion. Body changes its location with time. Then we say the body is in motion. So it is rest and this is motion. Now tell me, after watching this part of some of this video, you need to know that what type of state you are in. You are in rest state or you are in motion state. Think. My question is, yes, you are watching the different type of things outside and you're also believing that motion of a car, motion of a truck, or the walking, running is exactly a motion. Yes, I agree with you too. But motion is relative. That means if something is moving with respect to one person, the same thing need not to be in motion with respect to the other person. Let me explain. See this diagram carefully. It's a bus moving on the road is in motion. In the bus there are many passengers. I have located two passengers, passenger A and passenger B. And there is an observer on the roadside who is watching the motion of the bus. Now, according to the observer O, what is the state of the passenger A? Obviously, as the bus is in motion, in the bus everything should be in motion. So, according to O or according to observer, according to O or the observer, passenger A, yes, is in motion. Passenger A is in motion. Passenger A in motion. According to observer O, passenger B is also in motion because these two passengers in the same bus. Now, according to B, what is the state of the passenger A? Just think when you are traveling in your school bus, sitting next to your friend. What is the state of your friend who is sitting next to you? Yes, you are correct. Rest state. Yes. So according to B, the passenger A is at rest. See, I have taken the same passenger A in the two cases. In one case, according to observer O, he is in motion. In another case, according to B, he is in rest. That means motion is not exactly motion in all the time with all observers. For some observer, maybe the motion is in motion. For some observer, the motion is not motion, it is at rest state. So that's why motion is relative. A body, for somebody, it is in motion. But it need not be in motion for some other reference or some other body. So that's how we can say that motion is relative. One more example I will give you. Earth is rotating around the sun. So earth is in motion and we are staying on the earth. We are standing on the earth. We are living on the earth. What is the state of us? Do you think that we are also moving? No. At this moment, you are watching my video. You're at rest state. When this video is taken, I am also at a rest state. But Earth is rotating. So according to us, the people standing next to us are a rest state. But the same people are observed if they observed from other planet, say Mars planet. Now what do you feel? Yes, you are correct. As the Earth is rotating, the person standing on the or living on the Earth are also moving. They are in motion. So according to us, the persons next to us are in rest state, but according to Mars, they are in motion. That's where motion is relative. Now come back to our main topic, linear motion. So what is linear motion? The motion which is in straight line path is called linear motion. So straight line path, take an example of a car. A car is moving on the road on a straight line path. Then we say that a car is in linear motion. A person is walking straight on the road. Then we say the person is in linear motion. So linear motion basically is a straight line path motion. Straight line path motion. Now we take this motion in this chapter and we discuss many aspects of it, like the different physical quantities which are responsible to describe, understand this motion. So let us start with the first type of physical quantity, or you can say quantities. Distance versus displacement. Yes. Let us explore. I know that you have got some information, you know some knowledge of distance displacement, but I am giving guarantee that you learn new things by watching this episode. Now, what is distance? What is displacement? So let me explain you with an example. Take a path like this. There is a path. Okay, so there is a car. There is a car moving on the path. So start from point A, going to point B, going to point C, going to point D, and to E is the path. A to E it's going. A to B, the distance is 3 meters, B to C is 4 meters, C to D is 6 meters, and D to E is again 4 meters. But from A to E, the distance is 7 meters. Yeah, you see the diagram carefully. Now my question is, what is the distance traveled by the car from A to E? From A to E, distance. Tell me. Yes, you are correct. It is nothing but AB plus BC plus CD plus DE. That is, AB is 3 meters plus BC is 4 meters plus CD is 6 meters plus DE is 4 meters. So total how much? 3 plus 4 7, 7 6 7 7 6 13, 13 plus 4 17. It is 17 meters. The distance is 17 meters. Now coming to displacement. So what is displacement? To know what is displacement, first of all you should know what is distance actually. Distance is the total path covered. That's the definition. The total path covered. So I am writing here. Total path covered. Means in whatever the direction you are going, in whatever the road you are using, whole the path you need to consider for the distance. That's why even you have up and downs, each up and down we need to consider the total path covered. That's why all the sums you have taken, you got 17 meters. Now displacement is not total path covered, guy. It is the shortest distance between starting and ending point. Shortest distance between starting and ending point. So here starting point is A, ending point is E. So displacement is AE and the shortest distance is 7 meters. Yes, that's the displacement. So displacement is shortest distance between A and E. I mean to say between starting and ending point. Okay, one more information. Distance you got 17 meters, displacement is 7 meters. The one more information is distance is a scalar, displacement is a vector. Scalar means it has only magnitude. Remember, so distance is a scalar, only magnitude. Magnitude means number. So 17 is the number. It's only having magnitude. Displacement is a vector. I'm writing here. Vector means it has both magnitude and direction. So when I say magnitude and direction, the magnitude is 7 meters. We have understood. Now what happened to the direction? What is the direction in this case? Yes, you should be very careful that. When I want to tell the direction of any body, you need to take the earth directions, north, south, east, west. If they don't mention those directions, you should say right side, left side, top, bottom. Or sometimes we say the direction with respect to the x-axis with the angle, 30 degrees north, 30 degrees east, 30 degrees west, in that way. So in this case, if you see the shortest distance A to E, you can understand that the car is moving towards E. That means towards east side. East side you can say, or right side. So this is the direction of this displacement. We have learned about distance and displacement. Now moving ahead. Speed versus velocity. Yes, daily we say that so-and-so car is moving faster than the other car. And this bus is slower than the truck. I can say so-and-so friend, I am faster than so-and-so friend. So how could you measure quantitatively? See, I'm using the word quantity. Quantitative means numbers. How do you measure quantitatively that one body is faster than the other? Then physics helps you here with the physical quantity speed and velocity. So what is speed? Speed, which is represented by the symbol V and defined as the ratio of distance and time. That means distance divided by time. Distance is represented by the symbol S, time is represented by the symbol T. So therefore the formula becomes V equal to S by T. There are many definitions for the speed, but you should have clarity. Any definition you can take. Simply you can say speed is a distance by time, or you can say speed is a ratio of distance and time, or you can say rate of change of distance. Rate of change of distance. So any definition you can use. So the formula is V equal to distance by time, S by T. Now coming to this formula, what are the units? If you see the units, we have CGS and we have SI. Centimeter gram second, SI, of course it is also called MKS system. Now what is CGS unit of speed? Yes, distance unit is centimeter, time unit is second. So centimeter per second is the unit of speed in CGS system. In SI system it is meter per second. Sometimes we write like this, don't be confused. Meter second inverse. As a second is a denominator, when it goes to numerator, it becomes S power minus 1. So meter per second. That's a speed unit, V equal to S by T. Now, coming to velocity. It is also represented by the symbol v. Please pay attention here. At the speed is symbol is v, velocity symbol is also v. It is differed by the definition, not by the symbol. Symbols are same. When we have speed, why should we go for velocity? Because speed is a scalar quantity. It's a scalar. Means it has only magnitude, no direction. But in real life, it is very, very important to know the direction. If the car is coming towards you, one car is coming towards you in straight line path, exactly opposite to you. A bike is coming from left hand of yours. Then, if the car hits the bike, then which direction the bike goes? Or if the bike hits the car, in which direction it goes, we should know. Then only we can avoid the accidents, and we can either the car or the bike can stop immediately to stop the accident. So directions are very important. When you are in the ship is sailing on the water, on the sea water, and you are mid of the sea water, and if you are seeing around, you don't know in which direction you are in until unless you have the compass. The compass only tells you that you are towards towards north or towards south. Directions are very important. Same thing happens for aeroplanes also. When aeroplanes are flying in the sky, and if you see around, you can see nothing except the clouds in the daytime. In nighttime, you can't see anything. So, how the pilot knows that which direction he is going and how he has to reach to Hyderabad from Vizag is only possible by the compass. And compass gives the north and south directions. So, directions are very important. So, even though we have speed as a scalar quantity, we need to have a vector, and this velocity is a vector quantity. So, velocity definition is, it is the ratio of displacement to time. Displacement divided by time. Displacement divided by time. Displacement is S symbol again, time is T again. So, the formula wise, both are looking same. V equal to S by T, V equal to S by T. When both are looking same, their units also same. Velocity unit CGS is centimeters per second. Velocity SI unit is also meters per second. But only difference is velocity is a vector quantity. It has magnitude as well as direction. So, how do we differentiate both of them? We can know by solving the numericals. Yes, now you see this example, the previous example where we have found distance and displacement. This time the same example we take and we try to calculate speed and velocity. The body is in a circular path of radius 2 meters. It starts at point A and moving the circular path. When it covers half circle A to B, I want what is the speed from A to B or from A to B. Of course, I want velocity also. So, to find the speed from A to B, as the definition says, distance by time. So, V equal to what is the distance traveled? In the previous example we discussed, the distance is 2 pi r divided by 2, half circle. So, pi r. So, pi r means pi is 3.14, r is 2 meters, 3.14 into 2. 3.14 into 2. This is the distance traveled divided by time. The time taken is 1 minute. If you write 1 minute, wait. You are doing mistake. Always we need to tell the answers in terms of CGS or SI. And when you are taking time, it should be converted into seconds. But the time is in minutes. So, convert it to seconds. 1 minute equal to how many seconds? 60 seconds. So, therefore, the answer is 6.28 divided by 60. Now, by solving this, what is the answer you are getting? 6.28 divided by 60. You solve it. I am not solving. It is meters per second. That's the speed. Now, velocity, the same problem, velocity from A to B. Velocity V equals to displacement by time. A to B, the displacement shortest distance, 2 plus 2, 4. 4 divided by time, 1 minute, which is 60 seconds. So 4 by 60 minutes per second. Solve it and find the answer. This is how you can find the speed and velocity. I hope you solved the ratio and these are the answers. Speed 0.105 meters per second and velocity 0.07 meters per second. Okay, let's move on to the next concept called instantaneous velocity. What is instantaneous velocity? Instant means at that moment. If I say I have done this work at 4 seconds, I have done this work in 4 seconds. See the difference. I have done this work at 4th second, I have done this work in 4 seconds. So when I say I have done the work at 4th second, it is instantaneous at that moment. I have done the work in 4 seconds, so covered time, total time. So instantaneous means at that moment. So instantaneous velocity means the velocity you are telling or you are seeing at that moment. When you are in the bus or when you are in a car, the odometer, the speedometer, when you observe and the pointer shows at 10, coincides at 10, then if you say, yeah, it is 10 kmph, kilometer per hour, that means there is a speed of the car at that moment. But it is not the speed of the car in the whole of its motion, whole of its course of motion. No, it is at that moment only. Suppose you are in the car moves with the speed of 70 kmph, and driver says that yes sir, I'm started from the point called Secunderabad and I reached to high-tech city with the speed of 70 kmph, then he is not saying the instantaneous speed or instantaneous velocity. He is saying the average speed or average velocity. Instantaneous is at that moment. So that's how you need to differentiate instantaneous velocity and average velocity. The odometers, what are the speeds you are seeing at that moment, are only instantaneous. Okay. Now coming to this average speed and average velocity, how do we measure? In real life, we don't tell or we cannot tell the exact speed or exact velocity. We can tell only average speeds and average velocities. Theoretically we say speed velocity, but practically we are telling average speeds, average velocity, because when you start from Secunderabad and going to high-tech city, you know the traffic and you know how many turnings you need to take. In that situation, the car will take many number of turnings and the driver apply the brakes, driver accelerates the car, so the speed changes regularly or the velocity changes regularly. So you need to take all these velocities, all the speeds in consideration so to get an average speed or average velocity. So the speeds, the car, what you are seeing on them, what they say, what you tell are only average speeds once the motion is completed. So how do we measure? Yes, of course. Physics gives for each and everything formulas. Average speed and average velocity are also having formulae. Let me tell you. Average speed. The symbol what I am using here, V average, is just a symbolic representation. You can use any symbol you want. I have used AVG, short form of average, subscript of V. V average. So average speed definition is, it is a ratio of total distance to total time, or simply you can say total distance divided by total time. Right? Okay. Let me draw a diagram for you. So there is a point A, point B, and point C. A to B, the distance is S1. B to C, the distance is S2. The time taken is T1, time taken is T2. And of course, it's none other than a car. So A to B, the distance traveled S1, B to C, distance traveled S2, times are T1, T2. Now see the formula carefully. By the definition itself, we can write the formula. So V average equals to, symbolically writing, total distance S1 plus S2 divided by total time T1 plus T2. That is average speed. And what is the unit of average speed? The unit what I have told you, what I have taught you in speed, the same unit, which is centimeters per second or meters per second. Average velocity. Average velocity, the definition is V average equals to displacement divided by total time. That means you can say it's the ratio of displacement to total time, or simply displacement divided by total time. Okay, so take the same example here. The car moving from A to B, B to C. S1 is the distance, S2 is the distance. As the car moving the straight line path, the distance, displacements both are same. So S1 plus S2 is not only total distance here, displacement also, because same direction. But let me do a small modification. See here. Now see carefully. See the diagram. The car is moving from A to B, B to C, and C to B. C to B. C to B, the time taken is T3, say T3. Average velocity is displacement, shortest distance. So A to B, B to C, C to B. So what is the shortest distance? We learned earlier. Yes, it is correct. It is only S1. It is S1 divided by, but remember, total time. Don't say only T1. Total time need to take. So that is T1 plus T2 plus T3. So this is what average velocity. It has both magnitude and direction. And its unit is again centimeters per second and meters per second. Now we are going to discuss about acceleration. You may have heard many times about the acceleration when a vehicle is in motion. For example, like a car. When the car driver is driving the car, under his feet, or you can say under his foot, there are 3 pedals: clutch, accelerator and brake, in this order. Now see the center pedal, accelerator. So what it is used for? If you observe it, if the driver wants to increase the speed, he press on the accelerator. If you want to decrease the speed, where he press? It's a common sense. He presses on the brake button, brake pedal. So when you press on the accelerator pedal, the car increases speeds and moves faster. So we should know that what is actually acceleration. Acceleration is not speed. Action is a different thing. What is it? See here. A vehicle moving with initial velocity u. U represents initial velocity. Okay, let me write here. U is initial velocity. V is final velocity. T, time taken. U is initial velocity, V is final velocity, T is time taken. Always use the symbols for the same thing. Initial velocity, wherever you go in physics, it is U. Final velocity is V. Okay, now what is acceleration defined as? Acceleration defined as change in velocity divided by time taken. See how simple the definitions are. Change in velocity by time taken. So change in velocity means what you say. Is it u plus v or v plus u or v minus u? Yes. Whenever we say change, always need to take from initial value, need to be subtracted from final value, or I can say final minus initial. So it is v minus u divided by t. This is acceleration formula, a equal to v minus u by t. Now what is the unit? Yes, CG is the unit. See, v minus u, in the numerator you have velocity, so that unit is centimeter per second divided by second. So it is centimeter divided by second square. Now, what is SI unit? Centimeter, SI is meter, meter per second square. So remember this unit. Don't be confused with meter per second square. Meter per second is for velocity or speed. Meter per second square is for acceleration. Acceleration tells you whether the car is moving faster, whether the car is moving slower, because it is change in velocity by time. It depends upon change in velocity. A equal to V minus U by T is the formula. Now, coming to this numerical, let me explain you more in detail of acceleration. See this numerical. The car actually is at rest. 0 meters per second means no speed. No speed means a rest state at time t equal to 0. When the time increases at 2 seconds, it is at the speed 5 meters per second. At 3 seconds, it is the speed 10 meters per second. Then what is its acceleration, if I ask you? What is its acceleration? Yeah. So how do we ask? First of all, I need to say from 0 to 2 seconds, what is the acceleration of the car? Okay. When time t equal to 0 seconds to 2 seconds, what is the acceleration of the car? So acceleration is V minus U by T. So V minus U by T, V is 0 to 2 seconds, 0 to 2. The V is final velocity phi, initial velocity 0. The time interval is 2 seconds. I can say 2 minus 0. So you will get phi by 2, which is 2.5 meters per second square. So the acceleration of the car from 0 to 2 seconds is 2.5 meters per second square. That's the acceleration. Okay. Now coming to the second diagram. See the car here? If you see the two diagrams, in the second diagram, t equal to 0, 2 seconds, 3 seconds, 4 seconds, if you see the speed, 0 meters per second, 5 meters per second, 4 meters per second, 1 meters per second. So what's happened in second diagram? Speed is decreasing, 0, 5, 4, 1. In the first diagram, speed is increasing. When the speed is increasing, we can say the car is accelerating. When the speed increases, the change in velocity also increases. If the speed increases uniformly, the change in velocity increases uniformly. So in the first diagram, it says when the speed is increasing, the car is accelerating. But in the second diagram, the speed is decreasing. Then what we say? We say car is accelerating? Yes, you can say, but you can say car is negatively accelerating. Or you can say car is decelerating. Let me show you here. Now take the example from t equal to 2 seconds to 3 seconds. In the second diagram asked, what is the acceleration from 2 seconds to 3 seconds? Yes, you take a equals to v minus u by t. So in 2 seconds to 3 seconds, the final velocity is 4. So 4, initial velocity is 5, time is 3 minus 2. So 4 minus 5 minus 1 by 3 minus 2, 1. So this is minus 1 meters per second square. See here. Acceleration A equals to v minus u by t, and from 2 seconds to 3 seconds, the v is 4, u is 5. So 4 minus 5 divided by 3 minus 2. So you are getting minus 1 meters per second square. Here the acceleration is negative. Negative accelerations tells you that the speed is, or the velocity is decreasing. So that's why it is called, of course we say negative acceleration, but it's also called deceleration. See the spelling carefully. D-E-C-C-E-L-E-R-A-T-I-O-N, deceleration. Sometimes it is also called retardation. So, which word you feel easier, use that word. So, this is retardation. Now, if I go from 4 meters per second to 1 meters per second, what is the acceleration? Tell me. Use this formula, tell me the acceleration. And I am sure that you will get again negative value. So, negative accelerations are nothing but retardations. and in this case speed decreases. Positive acceleration, speed increases. Let us do two problems based on acceleration. There is a bus. This bus started its motion with velocity 80 km/h and gets its velocity to 60 km/h after 5 seconds. Then what is its acceleration? This is the question. Now, as you know that acceleration A is a v minus u by t, final minus initial divided by time taken. The final is 60 km/h, initial is 80 km/h by divided by time. If you see here, 60 minus 80 minus 20 by 5, but remember this is 20 km/h by 5 seconds. Now km/h we couldn't leave in that way, you need to convert it to meters per second, and I have told you the conversion. So kilometer per hour can be converted if you multiply with 5 by 18 to convert into meters per second, divided by 5 seconds, meters per second, if you want to convert into meters per second. Now if you simplify this, the answer you get minus 1.11 meters per second square. That is the acceleration, and if you see this is negative, so it is retardation. The bus reducing its speed, it's retardation. See the second problem. If there is a train, starts at rest, reaches to speed 40 km/h in time 10 minutes. What is its acceleration? At rest means you should know always initial velocity is 0, right? Then the acceleration A equals to again v minus u by t. Final velocity is 40 km/h, 40 minus initial velocity 0, and time taken is 10 minutes. So here also you need to convert everything into meters per second. So 40 km/h, if you convert it, you need to multiply by 5 by 18, which is meters per second, divided by 10 minutes. 1 minute equals to 60 seconds, so total seconds are 600 seconds. So if you simplify this, you will get the answer 0.0185 meters per second square. So far we have discussed about distance, displacement, speed, velocity and acceleration. In the beginning of the chapter, I told you that we have different types of motions, but in that our focus is on linear motion. And the linear motion also, again, we can have two types of motions, uniform motion and non-uniform motion. Now coming to uniform motion, the name tells you uniform. Uniform means constant, fixed. So see this table to understand what is this motion. In 0 seconds, the distance traveled is 0 seconds. S means distance, T means time, S slash M, distance slash the unit of distance, meters, time slash S, the unit of time, seconds. Yeah. So at 0 seconds, distance is 0, means the body is rest state. At 1 second, it covered 3 meters, 2 seconds, 6 meters, like that. Now, if you see the time interval from 1 to 2, in 1 second to 2 seconds, what is the distance traveled? 6 minus 3. So this distance traveled is 3 meters per 1 second. Now coming to 2 to 3 seconds, second to third second, the distance, how much distance traveled? Means 6 meters to 9 meters, but distance traveled is not 9 meters. Distance traveled is 9 minus 6, 3 meters again. So again it is 3 meters in 1 second. Now from 3 meters to 4 meters, 3 seconds to 4 seconds, similar, 3 meters per second. So if you observe carefully, this body covering equal distances, 3 meters, 3 meters, 3 meters, in an equal interval of time. I mean each 1 second it's covering 3, 3, 3. So that's why its speed is 3 meters per second, 3 meters per second, 3 meters per second. So the speed V is constant throughout. So uniform motion means the motion with constant speed. Constant speed. Of course, you can say constant velocity if the body is in straight line motion. Perfect. Motion with a constant speed. Or you can say body covers equal distances in equal time intervals. Equal distances in equal time intervals, or the motion with a constant speed. And in this example, the constant speed is 3 meters per second. That is uniform motion. Now coming to non-uniform motion, the opposite of non-uniform motion. See the table carefully. In 1 to 2 seconds, the distance traveled 3 meters to 4 meters. The distance traveled is 1 meter. 1 meter in 1 second. Now from 2 seconds to 3 seconds, the distance traveled is 4 to 9. Means 9 minus 4, 5 meters in 1 second. Now from 3 to 4, the distance traveled 14 minus 9, which is 5 meters in 1 second. So what happened here, speed is not constant, speed is changing. So therefore, we can say it is speed differ. V differs. So here motion with different speed. Of course, you can add, you can say velocity also, or body covers unequal distances. Unequal distances in equal time intervals. In equal time intervals. Sometimes you can say this also, body covers equal distances in unequal time intervals. Either the way, it is non-uniform motion. So basically you should know that the body moves with constant speed. In this example, 3 meters per second. The body moves with a different speed. Different speeds like that. 1 meter per second, 5 meters per second. Now let me explain you in detail graphically. Let us take a graph which is having x-axis and y-axis. This is x-axis, this is y-axis, this is origin. I will take time on x-axis and distance in y-axis. Now time 0, 1, 2, 3, 4. No? So let me locate the times 1, 2, 3, 4 seconds, and distances 3, 6, 9, 12 distances. It should be equal distances. 3, 6, equal space. Yes, now it is little better. Now 0 seconds, 0 distance. So first point is located here. Okay, let me keep like this. Cross is location, 0 seconds, 0 meters. Next is 1 second, 3 meters. 1 second, 3 meters. See, one more point is plotted. 2 seconds, 6 meters. Right. Now 3 seconds, 9 meters. Now, similarly, if you plot the points, so approximately plot the points. If you join all the points, if you see carefully, you will get a straight line. A straight line. So whenever you see the distance time graph as a straight line, without any doubt you can say it is uniform motion. It is uniform motion and speed is, okay, earlier we have calculated 3 meters per second. So this type of graph represents uniform motion. The line, straight line passing through origin. Now non-uniform motion. Let me draw the same graph with the same rules. x time taken in seconds, 0 y-axis, so this is distance in meters, time in seconds. Again, locate the times and distances 3, 6, 9, 12. Okay, let me extend this, 12, 15. Okay, now see what happens. 0, 0 located, 1 is 3 meters, 1 is 3 meters, 2 is 4 meters, 4 meters. So let us say this is 4 meters. Okay, let me plot here, 4 meters. 3 seconds is 9 meters, 3 seconds, this is 9, 3 seconds, plotted, 9 meters. 4 seconds, 14 meters, 14 comes here, this is 14 here, so 4 seconds, this is the plotted approximately. Now if you join the points, if you observe carefully, now this time you are not getting a straight line, you are getting a curve. That means in a distance time graph, whenever you see a curve, it is obviously a non-uniform motion. Now we will explore the second graph, velocity time graph. So whenever you take time on x-axis, velocity on y-axis, then it's called VT graph, velocity time graph. So let us go in detail of velocity time graph. Let me take an example. So x-axis time in seconds, y-axis velocity in meters per second. Yeah, meters per second is unit of velocity. Now the times are taken 2, 4, 6, 8 imaginary time intervals, and the corresponding speeds I'm taking 0.1, 0.2, 0.3, 0.4. These are the speeds, or you can say velocity. These are the times. Now at 2 seconds of interval of 2 seconds of time, the speed of the body is 0.1. At 4 seconds of time, the body speed is 0.2. Now at 6 seconds, the body time is 0.3. Similarly, 8 it is 0.4 meters per second. Now once again, if you join the points, without any doubt you can say that it's a straight line passing through origin. Yeah, it's a straight line passing through origin. So whenever the line is straight in VT graph, what is the state of the body? What you want to say about the state of the body? In the previous example, ST graph, I told that the body is in uniform motion. When the body is in uniform motion, its speed constant. But if you see this graph here, the velocity is increasing uniformly. The velocity is increasing uniformly. That's why you get a straight line graph. Okay, when the velocity is increasing uniformly, you can say the change in velocity with respect to time is constant, right? So this graph says velocity increases uniformly, means change in velocity implies change in velocity is constant. Whenever change in velocity is constant, then change in velocity by time is what? Correct, it is acceleration. So it has uniform acceleration. Yes. So whenever you see this graph, you can tell that velocity increases uniformly, or you can say that the body is having uniform acceleration, means constant acceleration. Now your question is that how do we find the acceleration using this graph? So let me tell you. To find acceleration, the graph is giving two types of information for you. First thing is the number one, state of the body. As I told earlier, in ST graph. State of the body, this also gives state of the body, whether the body's velocity increasing or decreasing. Now second, it gives acceleration. And I told you, we are going to find acceleration of this graph. And how it is? It is possible by taking slope or gradient of the graph. So slope or gradient of VT graph gives acceleration. Same mathematical formula, y2 minus y1 by x2 minus x1. So take any on y-axis any 2 points as y1 and y2. So let me take 0.1 as y1, 0.2 as y2. You can take this is y1 and that is y2. It's your choice, but be careful. Corresponding thing you need to take x1, x2. So y1 corresponding to is x1, y2 corresponding thing is x2. That should be careful. So y2 minus y1, 0.2 minus 0.1 divided by x2 minus x1, 4 minus 2. 4 minus 2. So 0.1 divided by 4 minus 2, it is 0.1 by 2. So what is the answer? You are correct. It is 0.05 meters per second square. See the beauty of this graph. So this graph not only tells the state of the body, it gives the acceleration also, 0.05 meters per second square. Right? So there is only possible slope. Now we have one more advantage. We can find the distance traveled by this body using VT graph. Distance traveled. Distance traveled. Or I can say displacement traveled. If we say V is speed, distance traveled. If V is velocity, displacement traveled. Anything. So how do you find? This can be possible by area of the graph. Area of the graph. Now you ask me a question that how do you find this distance? Take an example. From t equal to 2 seconds to 6 seconds, what is the distance covered? To find distance from VT graph, let me take an example. Okay, from t equal to 2 seconds to 6 seconds, what is the distance covered? Let us solve. Implies t equals to 2 seconds to 6 seconds, distance we want. Okay, see the graph carefully. 2 seconds, let me put some labels for this. A, 6 seconds is B. So this is the line, this is the B, solid line you see. Now 2 to 4 seconds says this is C, this is D. Now what happened? It is the area of ABCD. As I told you, distance traveled you can find by using area of the graph. And here area of the graph is nothing but ABCD, because I asked 2 to 6 seconds. So 2 to 6 seconds only we have taken. Now what is the area of the graph? How do we find? So for this, what we do, there are 2 ways I will tell you. First we take the simpler way. From D, you draw a line. Take that intersection point is E. Now this area ABCD divides into 2 areas. One is ABED rectangle. The other one is DEC triangle. Therefore, the area is nothing but sum of area of rectangle and triangle. So rectangle is ABED rectangle area plus area of CDE triangle equals to, okay, it's very simple. Rectangle area is what? If your length is the L is the length, B is the breadth of rectangle, the area is length into breadth. And here see, length, breadth, AD into AB. So AD into AB. This is the area of the rectangle. And triangle, what is the area of the triangle? Half into base into height. So half into base. DE is the base. DE is the base into height. This is the height, C. Now quickly substitute the values. AD value, so this is the AD value 0.1 into AB 6 minus 2, 4, guys remember 6 minus 2, don't say 6, AB in a difference need to take 6 minus 2, 4, okay, plus half into DE 6 minus 2 again 4 into CE 0.3 minus 0.1, so this is 0.2. This is what the calculation. Now we need to solve to find the result. So let me do it here. What is the result? 0.1 into 4, 0.4 plus half into base, so 2, so this is 0.4. So the answer is 0.8 meters. That's the distance traveled by the body. After understanding and knowing about different physical quantities starting from distance, displacement, speed, velocity, acceleration, average speed, average velocity, now it is the time to solve advanced level numericals. Like, you know speed, distance traveled, but you want to find what is the time taken. You know time taken, speed, initial speed and final speed. You want to find what is the distance traveled. Or maybe you have dropped a ball from a tower and you want to know what is the speed of the ball when it hits the ground. So this type of questions, if you want to solve, we need to know equations of motion. These equations are also called kinematic equations. Kinematic equations or equations of motion. And we have, importantly, 3 equations. And you need to remember those 3 equations. Number 1, V equals to U plus AT. All symbols meanings you know. V is final velocity, U is initial velocity, A is acceleration, T is the time taken. Now second one, S equal to UT plus half AT square. S is the distance traveled. Now third one, V square minus U square equal to 2AS. Now register these 3 formulas in your mind. You need to remember these equations. But here I am going to derive these equations graphically using VT graph. If you see this VT graph, a straight line is drawn. The straight line tells that the body has some initial velocity u. If the graph line starts from here, then I can say body start from rest because v equal to 0. But here v is u. So the body has initial velocity u and reaches to final velocity v in time t. So in this situation, we need to derive these equations. So let me derive the first equation, v equal to u plus at, which is called speed time relation, or you can say velocity time relation also. Okay, now see this graph. Now I'll do a little improvement in this graph. Say this is a symbol is A. Now drawing a line here, say this is a this is B, this is C, this is D, this is E. These are the labels I have kept. The original graph is AD only. All remaining or dotted lines are imaginary lines which are helping for us to solve those equations. Now, you see the line DB, DC. When the graph moves from A to D, take the line DC. So how do you find this DC? You can find DC by writing DB minus, say DB minus CB. See carefully. So from the graph I have taken a line DC, and to find DC, what I have done, I have taken total line DB and subtracted CB, so that I get DC. Correct. Now what is DC here? To find DC, write the DB value. What is DB? See here, DB, 0 to V, that means V velocity, the final velocity V, minus CB, 0 to U, so the difference is U, the initial velocity U. So DC is V minus U. Now take AC. I want AC value. AC is nothing but T. Obviously from the graph AC is nothing but OB. The OB, the time taken is T. VT graph, earlier I have taught you that to find acceleration, slope of VT graph we need to use. So acceleration A equals to slope of VT graph. Now slope, in this diagram, the slope formula I have told you that y2 minus y1 by x2 minus x1 you can take. See, this is y2, this is y1, y2, y1. So if you say like that, this y2, y1, the difference is y2 minus y1. y2 minus y1 is nothing but DC. So acceleration A is DC by x2 minus x1, x2 minus x1. The x2 minus x1 is nothing but OB, or I can say AC, and the AC is T. I am writing AC here. So DC is V minus U divided by AC is T. So what we got? A equals to V minus U by T. Now do the cross multiplication. Then what you are getting? A into T equal to V minus U. Take U to the left hand side. So at last you got AT plus U equal to V, implies V equals to U plus AT. So this is what called velocity time or speed time relation. Now we need to derive the second one. It is called position time relation. Take the same graph. Here, if you want to find distance, yes, distance traveled, I told earlier to you that you need to use area of the VT graph. So area of the graph here, the graph starts here and ends here. The area of the graph is whole the thing, A, O, B, C, D. That's the entire area. So S equals to area of OA, area of AO, BC, D. That's the entire area. AO, BC, D equals to find a big shape area, what we do little simplification. The simplification is that, see that the graph once again, the graph divided into two parts, rectangle and triangle. So I can say area of rectangle OACB plus area of triangle ADC. Now the rectangle OACB, the value is OA into OB, the formula, length into breadth, plus triangle half into base into height. The base is AC, height of triangle is DC. Good. Now what is OA? Now see the graph carefully. OA is U. U into what is OB? OB is nothing but T. T, U into T plus half into what is AC? AC is nothing but OB, again T. T into what is DC? DC is nothing but VU, difference. So it is V minus U. So V minus U. So UT, I can write UT plus half into t into v minus u. Okay, but this is not our formula. Some changes happening here. If you see the previous expression, v equal to u plus at, if you reframe it, you will get to know that from this first equation, v minus u is nothing but a into t. Yes, you see, take u to the left hand side, v minus u equal to at. So substitute this at here. So ut plus half into t into, instead of v minus u, I am writing at. So at last I got ut plus half a t square. This is what the distance formula, which is also called position time relationship. Now we are going to derive the third equation, which is also called position velocity relation. Now see the graph again. Again we depend upon the distance from this graph, which is the area of VT graph. So S equals to area of VT graph. Now it is nothing but area of A, O, B, C, D. Now same shape I am taking like earlier, but this time I am not taking the shape as a sum of rectangle and triangle. I am seeing the shape as trapezium. It's a trapezium shape. When you take trapezium shape, trapezium formula is sum of the opposite sides into height divided by 2. Sum of the opposite side means, see, this is one side OA, other side is DB, opposite sides, and the height is this one AC. So sum of the opposite sides OA plus BD sum into the height AC whole divided by 2. This is the trapezium formula. Equals to, what is OA? As I have substituted in the earlier case, OA is nothing but U plus BD is nothing but V, AC is T by 2. Have we got the formula? No. Yet we need to solve. Now see, from this equation 1 again, what is T value or T formula? Take U to that side, so V minus U, and A comes to denominator. So T is V minus U by A. So here the next step, instead of T, you write V minus U by A. Now see here, it is U plus V, or else I can change it as V plus U. Both are same. So V plus U into V minus U. Just think about mathematics. A plus B into A minus B. It's nothing but A square minus B square. So V square minus U square by 2A, which is equal to S. So implies 2AS equals to V square minus U square. So this is the equation what we wanted to derive, and this is what called position velocity relationship. So we had derived the equations of motion. Now it is the time to use these equations to solve problems. So let us start. The first one, a bus starting from rest moves with a uniform acceleration of 0.1 meter square for 2 minutes. Find the number A, speed travel, B, the distance traveled. So how do we find? When you want to solve these numericals, first of all, you need to identify what is the data given here. So first try to write the data from the question. See here, a body is starting from rest. Rest is the keyword here. So rest means always initial velocity 0. So you can write u equal to 0. Moves with uniform acceleration of 0.1 meters per second square. So it's an acceleration, a equals to 0.1 meters per second square for 2 minutes. Time t equals to 2 minutes, but wait here. Always we need to convert time in seconds. So 1 minute equal to 60 seconds, So now 2 into 60, 120 seconds. Now this is the data, these are the data given to us. Now we need to find speed required, the first one. The second one is the distance traveled. So first we find the speed required, A. Speed required means we need to find V. So if you see here, U you know, A you know, T you know, you need to find V. Now go back to the equations. So think which equation is the correct match for this numerical. Solve this numerical before seeing this video. You pause it, solve the numerical, then play again and check your answer with my answer. So the equation is V equal to U plus AT. So use V equals to U plus AT. So you need to find V. U is 0 plus acceleration 0.1 into time is 120 seconds. So this is nothing but equal to 12 meters per second. That is the speed. But you will get a confusion that we are using acceleration but you are finding speed. How? Acceleration is a vector, so we need to find velocity, but they have mentioned speed. The only thing is that here the body is in straight line motion. In straight line motion, speed, velocity both are same. Now the second one, the distance traveled. So I am doing it here, the distance traveled. So you need to find S. Now check the equations again. You know U, A, T, you need to find S. Yes, you are correct. The second equation. So S equals to UT plus half A T square. So equals to U is 0, 0 into T plus half. A is how much? 0.1 into T, again 120 square. So if you simplify this, you will get 0.1 into 120 square divided by 2. And if you simplify it, the answer is 720 meters. That's all, you solve the problem. Now the second numerical. A train is traveling at a speed of 90 km/h. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meters per second square. Find how far the train will go before it is brought to rest. Now this is a little different from the previous problem we have solved. As I told you, before solving the numerical, find out the data given here. So first of all, see, the train is traveling at a speed of 90 km/h. See the diagram here. Always it is a good practice to draw the diagrams based on the data given to us. So train whose initial velocity 90 km/h and move with the acceleration of minus 0.5. The acceleration is negative because the brakes are applied. When the brakes are applied, speed decreases uniformly in this case. So when the speed decreases, the acceleration is negative. This negative acceleration is also called retardation. Already we have learned. So now after some time, it reaches to rest. When it reaches to rest, its final velocity V equal to 0. So the question is asking how far it has traveled before it reaches to rest. So you know U, A, V, you need to find S. So go back to the equations of motion. Which equation is suitable for it? Yes, you are correct. The third equation. So write the third equation V square minus U square equal to 2AS. Final velocity V equal to 0 square. Initial velocity 90. Stop here. 90 km/h. SI unit is meters per second. So you need to convert 90 km/h into meters per second. So how do we do? See here how I am doing. If you want to convert kilometer per hour into meters per second, multiply with 5 by 18. Now this has become 18 5 is 90, 5 5 25. So this is 25 meters per second. So come back to U square. It is 25 square equals to 2 into negative acceleration minus 0.5 into S. So in this case, you need to find S. So it is 625, 25 minus 2 into 5, 10, but because of decimal, it is 1. So 1 into S is S. So negative cancelled. So the answer is Distance traveled equals to 625 meters. Third numerical. A trolley while going down an inclined plane has an acceleration of 2 centimeters per second square. What will be its velocity 3 seconds after the start? If you see this diagram carefully, trolley is at the highest point and it is initially rest u equal to 0 and it started moving down the inclined plane with an acceleration of 2 centimeters per second square, and here we are asked to find the final velocity after 3 seconds. So we know u, a, v, t. We need to find v. So which equation can be useful? Yes, obviously the first equation. So write it down here, v equal to u plus at. So v equal to u is 0 plus acceleration is 2 centimeters per second square. Wait here, you need to convert into meter. So centimeters meter, 1 centimeter equal to 10 power minus 2 meter per second square. Okay, is acceleration is given and time is 3 seconds. 3 seconds. Okay, now 0 plus. So if you multiply 2 into 3, 6 into 10 power minus 2 meter per second, because it is 3, it is second. If you remove the 10 power, you will get 0.06 meters per second. This is what the final velocity we required. The fourth numerical. A racing car has uniform acceleration of 4 meters per second square. What distance will it cover in 10 seconds after the start? See the diagram here? Its acceleration is 4 meters per second square. And after the start, so it starts, how it starts? It doesn't start with some velocity, it starts from rest. So when it starts from rest, we take u equal to 0. Right. After 10 seconds, it has covered some distance, yes, with this acceleration. You need to find the distance, yes, you need to find. So which formula we can use? S, T, A, U. If you check the equations of motion, you understand that the second equation is suitable for this. So let us write S equals to ut plus half at square and equals to u is 0, so 0 into t plus half into what is a 4 meters per second square into time 10 seconds, so 10 seconds square. So what we get? 0 plus, it is cancelled, 10 square is 100, 100 to 200. So the answer is 200 meters. The next concept, circular motion. Why we have introduced circular motion in this chapter? Motion. You get to know within few minutes. See this circle shape. The circle shape resembles the circular motion. If any body starts at point A and moves in a circular path, we can say it's a circular motion. You are correct. But in physics, I told you, we have some rules. We need to be very specific to define any type of motion. So at point A, if you see, and if I ask you that, at what speed the body is moving, how do we tell? We can tell using the tangent. So you draw a tangent at point A along the circle, and that tangent gives the speed, direction. And what is the value? We need to calculate. But at A, if you want to know the direction, you need to draw the tangent. So tangent gives the speed, direction. Now locate one more point here, let's say C. And now if I ask you that what is the direction of the motion at point C? Again you need to draw a tangent. So that is the direction of speed. And at point B also I am asking you. So again you draw a tangent. And that is the direction of speed. And at last, if I look at a point here and ask you the same, what is the direction of motion? Again you draw a tangent, and the tangent gives the direction of speed. So in all these cases I am mentioning the direction of speed. That means speed has direction. When speed has direction, it is called velocity. So this V is velocity. So at each and every point the velocity changing its direction, but it is constant in magnitude. So according to physics, circular motion is actually uniform circular motion. So we need to say uniform circular motion because the definition says a body is in a circular path. A body is in circular path with constant speed. Then it is called the body is in uniform circular motion. So I mentioned constant speed. So V equal to constant. It's constant, but its direction changes. That's why the velocity direction is changing. In uniform circular motion, body has acceleration. Implies it has acceleration. So we say uniform circular motion is also accelerated motion. See what happened now. These two are same now. That means if you want to give any example for accelerated motion, circular motion you can give. Okay, we understood about the direction of velocity, and when I mention accelerated motion, it has acceleration. So what is the direction of acceleration? Because acceleration is a vector. See the diagram carefully. Acceleration is always towards the center. This is acceleration direction towards the center. Always. See here also. If you draw a line, as you know, these are the radii of the circle. So always it is toward the center. See? Toward the center. Axis is toward the center. Always is towards the center. But the question comes, why it is? Why axis is towards center? You will learn about force in the next chapter. But here I wanted to give us a little information about it. According to the force formula, force is mass into acceleration. So acceleration is here. The body, if the body is at the point A, the body has mass. So mass into acceleration, force. So this force is actually acting towards the center. And this force making the body to be in the circular path. And that force is called centripetal force. Okay? The force which acting towards the center is called centripetal force. And its formula is mass into acceleration only. So that's why you can say this acceleration is called centripetal acceleration. Centripetal acceleration. So this force actually pulling the body in the circular path at each and every point on the circle. That's why the body is in the circular path. Suppose think that the centripetal force stops working here at the point A. Now the question comes, where the body goes? Does the body is in the circular path? No. The body will move in tangential path because the velocity is along the tangent. So that's why when you are whirling a rope tied to a stone like this, and if you leave that string or the rope suddenly, then what happens? It doesn't move a circular path. At what point you left, from that point it goes in a straight tangential path. And circular motions, we have so many practical examples in physics, in real life situations. Take the example of our solar system. All the planets revolving around the sun in circular motion. Specifically our planet, Earth and sun system, if you take, this is sun, and around the sun Earth is rotating. Around the sun Earth is rotating in this way. And so we can say it's in circular motion. And we can say that the centripetal force is working on the Earth, making Earth to rotate around the sun. But the question is that centripetal force is not actually a real force. some force is acting like a centripetal force. And in this case, if you see, sun is attracting the earth, and that attractive force is called gravitational force. So in this case, the gravitational force, or I say G force, gravitational force is acting like centripetal force. Now, second example. Electron nucleus system. Electron nucleus. Just go back to your atomic models, what you learned in your classes. Is the nucleus, around the nucleus you have electron revolving around it, around the nucleus. It is also circular motion. It is also because of centripetal force. But here the centripetal force not actually acting. Some force is acting like centripetal force, and here we say Coulomb force. Coulomb is the scientist name. So here Coulomb force, C-O-L-O-U-M-B, Coulomb force is acting like centripetal force. Centripetal force, Coulomb force. Now the third example, what I have mentioned earlier, a person standing on the ground, and he has taken a rope or string tied to a stone, okay, and it's whirling. So the stone is in circular path. Here also centripetal force acts, but here the tension in the string, the tension in the string, here it will be like this, tension. The tension in the string works like a centripetal force. So tension equals to centripetal force. Right? So what we have learned here in this case, that we understand what is circular motion, why it is called uniform circular motion, and different examples of circular motions. And also I have mentioned about the centripetal force, which keeps the body in the circular path. Now more about centripetal force you learn in higher classes.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.